Greetings, the Astro 30 here yet again, and welcome back to AEL. Now, if you're new to this channel, please consider going down below and subscribing if you haven't done so already. Cheers. Today's the day that I'm going to assemble the AEL 2011 Power Amplifier's power supply module. I've got a bag of parts and a lot of time on my hands. Well, not quite a lot of time. So first, I will open the bag and we'll get a PCB out. And there it is there, just hang on a sec. I don't know if it's just me, I just love smelling PCBs. It's probably poisonous too. There's the front side of the PCB. I've got places here for the NE555, and the speaker relay, and a heatsink, which I have to make sure that fits in the board. However, I had made a change from the original breadboarded version of this, and I'll put a link in the description to that video. Originally it only had one diode going into this series pass regulator, so it was only half-wave rectified. When I connected 24 volts AC to the breadboard, what happened was I took out the Zener diode, that went away. Therefore, I ended up with 30 volts DC going to the rest of the circuit here. Took out the 555 timer because, well, I exceeded the maximum voltage rating of the timer and blew that up. But I didn't blow the relay up, so it had 30 volts sitting at the relay, but it still seemed to work fine. Although I wouldn't want to run it for a long period of time connected to the relay because it will eventually burn it out. So, I've made the modification of making it a full wave rectifier with reference to ground. So we've got one diode coming in rectifying one half wave, and a second diode coming in on the other side of the transformer rectifying the other half wave. So we've got now full wave rectification in here because I've built this regulator circuit before on both the AEL-2011 power supply module for the amplifier, plus my bridge-tied load 200 watt base amplifier uses the same circuits, and in this case a 555 timer and the BTL amp, and it hasn't blown up yet, so I don't know. It could have also been that the value of this resistor was too low. It's now 4K7, 1 watt, instead of 2K2. So there we go. The filter capacitors are just 6800 microfarad 50 volt snap-in jobbies. Got the underside here. Now this is important. The circuit will not work if the thermal switch is not installed. It has to be a normally closed thermal switch. So if you're not using the thermal switch or the J3, which is its header connector, then you need to install a wire link across the header. So before I test this, I'm going to have to short out J3 basically to make the circuit work, or else the relay will never engage. So that's one thing. I've made it pretty obvious where the positive and the negative points are on the board here. It can support two modules. Got an extra header connector here for the plus minus 35 volt DC out to go into another circuit such as a preamp using its own, say, shunt regulator to drop the voltage. So that's access to the supply rails of the power amp without having to solder wires underneath, etc. So what I need to do is I need to verify that my heatsink's going to fit in that footprint. Here's the heatsink here. It's from Ultronics. It's H0655. It's 42 millimeters high, I believe, by 16 by 16. Okay, so here's the heatsink, and just for verification, yeah, it's actually 44, not 42. Okay, solved that mystery. Not that it was a mystery, but yeah, fits in there perfectly with a little bit of overhang, which is not too bad. I mean, that's perfectly acceptable. There was plenty of space on the board anyway. I could have shifted it over that way, because, yeah, well, yeah. But no, that fits in good. So I just want to make sure my relay fits in the hole. There it is there. I'm just using one of the JW series Panasonic relays, DPDT. That was another change I made to the circuit. I was using two relays, separate relays originally, and it didn't make sense to do that. You don't have to use this specific relay. You can use an OM-ROM relay with the same pin layout, etc. As long as the coil current is, you know, around about 40 mA, should be fine, and 12 volt DC. So I'll just make sure that this fits in the holes. Oh, perfect. Excellent. So I'm not going to have any fitment issues. The filter cap should fit because I never changed the footprint size on that. The bridge rectifier now, yeah, that may be another issue. So I'm using one of these KBU 604 flat pack style bridge rectifiers here with negative AC positive with a chamfer to indicate positive, but also available from JCar, and it's a 400 volt 6 amp bridge, and that lives this way around in the board, and it looks like it is going to fit through the holes. Excellent, and it clears the filter capacitors fine. It's a bit close to the header connector, but in general that should be fine. It could sort of like live over at a slight angle anyway, just to clear the header. But no, it all looks good. Everything seems to fit. I am going to need 9 spade terminal connectors, and they're also available in packs of 8 from JCar for about $2.95, I think it is. The spade terminals, it doesn't matter where you get them, as long as they're for the 6.3mm spade headers or terminals, and that the pin width or pitch is 5mm and the pin diameter on each of the pins is no more than 1.1mm. Ultronics sell them as well, but they're like close to 2mm, I think it's 1.6 or something, diameter of pins, and they're not going to fit in the board. Not unless you take a file to them and file the pins down to get them to fit. But I'm sure the ones that JCar sell you can find like in the hundreds from China somewhere, but there's no real idea what the manufacturer is. It is a Digitech brand, but that could be from anywhere. Anyway, I'm kind of getting sidetracked, so what I'm going to do is I'm going to assemble this up in time-lapse, and we're going to build it and then test it, but we'll just have a look at the complete schematic first just so you can see what's going on, and then we will assemble it. Okay, so here's a brief look at the schematic. I am not going to go into too much detail. I'm only going to just show the changes that I've made from the original circuit, which is linked in the description, using the 555 timer. I've changed the rectification over here from half wave to full wave, adding this extra diode in, because as I said, this Zener diode went open circuit, therefore this was no longer regulating at 12 volts and sent 30 volts up the arse of the 555 and blew it up. The only other thing happened was the transistor did start to get quite hot, but it survived. So I'm not sure why the Zener diode blew. It was a 2K2 here originally, now it's changed to 4K7 as per another design that uses this circuit and works fine. Whether it was because this capacitor isn't able on half wave to maintain a steady enough DC voltage, so it was actually experiencing quite a bit of ripple across that diode, I don't know. The other thing to remember is J3 needs to be shorted for the circuit to work. So in my case, I'm going to put a link wire in there, and if I decide to use the thermal switch, I can just simply remove the link and put a header in. Other than that, not much has changed from the original circuit and its description. So if you want a better description of how this circuit works, well, the original videos to this are linked in the description, so if you can watch them if you haven't done so already. I'm going to get on to now assembling this in time lapse. I'm in two minds about putting the relay in or leaving it out until I've done some voltage measurements at this regulator circuit once it's running on a transformer. I'm going to start at 15.0.15 just to test it. If it proves to be okay, I'll install U1 in its socket. I'm going to use a 8-pin dual inline socket, and I will install the relay, but it might be harder to install the relay once the filter caps are installed, so I don't know. I'll decide once I've got most of the components on the board. I won't be putting the series pass transistor or its heatsink on the board yet because I have to do that separately. That is, isolate it from the heatsink and put a screw in it, and then put both assemblies into the board so everything lines up nice and straight, tighten the screw, then solder the heatsink and the transistor. Alright, so let's get busy doing some soldering. Well, about 20 minutes later, I've actually got the board mostly assembled, bar the transistor, heatsink, filter capacitors and the relay. The IC is also not installed. Now, the reason I've done this is because I want to do a preliminary power up test just with no load, just to make sure there is 12 volts there and the Xeno doesn't go away like it did on the breadboard version. I've been thinking it may have blown the Xeno because there more likely was a short between a couple of components on the breadboard. It's just the nature of breadboard. That would make more sense. I can't see any reason why a half-wave rectified AC signal versus a full-wave rectified AC signal would kill a Xeno, you know. And the thing's only drawing like probably a total of 85 mA. So, but what I want to make sure of is because when that Xeno blew, this transistor was providing, well, 30 volts out the other side of it from its emitter to the rest of the circuit, and it was around about 85 mA, and this was getting really, really hot. So I want to find out before I mount this to the board whether this transistor is still okay compared to a brand new one, or whether I should use the brand new one. So I want to measure the HFE. So I'll use my component tester for that, and I'll turn it on. I'll plug the transistor in. So there's our HFE, and it says it's only 35, which seems suspiciously low. It may be right, I don't know. I'd have to check the data sheet for the TIP41C, but I'll measure a new one. 52. Okay, so I think it would be a good idea for me to actually look up the data sheet for the TIP41C and see what its HFE should be. Well, that confirms it. The minimum HFE is 30. And there's another minimum here, but this is with different IC currents. So with an IC current, which is current through the collector of about 300 mA, with the VCE of around about 4 volts DC, the minimum HFE should be 30. If where current at the collector is 3 amps DC and the VCE is still 4 volts, The minimum is 15 and the maximum is 75. So that probably means that both these transistors are fine, but considering the HFE of this one measures higher than that one, this one's 53, this was 30 something, I'm going to use this one instead. Okay, so this procedure is going to require a isolator, steel washer, it's a bit dirty but that's fine, an M3 5mm screw and a TO220 bushing. So if I can grab hold of things it'd be nice. I just want to make sure that this is going to be long enough. Yeah, it should be. So I'll put that through the transistor and I'll put the seal washer on the device, and then I will mount it to the heatsink just loosely. I don't want to tighten it up yet, so I can get it into the board, and I've lost my screwdriver. So I'll just lightly tighten it. Just loose like that should be fine, maybe a little bit more. I'll still be able to move that seal washer around. And we'll bring the board in, and then I will feed the transistor in through its holes and then the heatsink into its holes, and that makes things nice and straight. So what I'll do is I'll solder the heatsink in firmly first before the transistor. Now this may take quite a bit of heat to do because, well, there's a lot of metal there. It's mainly to make sure that the heatsink is straight. And so I'll just solder one of the pins, and then I'll just double check that everything is lined up. Looks like it. That's perfectly fine. So then I can solder the other pin. Didn't require as much heat as I thought it was going to. Okay, so that's perfectly fine. So now I can actually make sure that that seal washer is straight and tighten the screw. I might have to loosen that back off again just a little because the seal washer won't move. If I can just move it over like a millimetre or so, that'd be great. Well, it doesn't want to, so it's straight enough for the most part, so I'm going to leave it like that. I'm going to tighten that screw. Okay, and I'm just going to hit this capacitor on the end there with the soldering iron because it's not straight. And that's better. And then I will solder the 3 pins of the transistor and snip off the excess. So I don't think that quite soldered properly. Alright, and if I can get in there, collector. And that should be the emitter. Okay, so that's the transistor soldered in. Snip off my excess lead length here that's not needed. Excuse me. And now I'm ready to do a preliminary test. So I'm going to use a 15015 volt transformer for the test because I don't have a 25025 one. But that's fine. And I'll just measure across pins 1 and 8 of this IC socket, and we should see 12 volts DC, roughly thereabouts. But I'm going to put some standoffs on the screw holes of the perimeter of the board here, just so it's up off the desk. I'm not going to worry too much about the filter caps not being in. It's only going to be powered up for a few seconds just to run the test. And I'm not going to put the relay in yet. I don't want anything loading on this transistor yet until I've verified that the voltage is correct. Then I'll put the relay and capacitors in, and then I'll remeasure the voltage, and finally I'll slip an LED in there to see if the timer circuit functions correctly, and then I'll run the protector tests. So let me get set up for powering it up, and we'll come back in just a few moments. Alright, I've got the transformer configured to 15015. That's the center tap point there. I only need one because the board's physically wired together between the two center points anyway. So I'm going to plug in my multimeter across the two AC ends. It's going into my dim bulb. I just want to make sure I've got close to 30 volt AC there. So turn it on. And I don't. So there's something not quite right here. Oh, that's DC voltage, that's why. There we go, 27 volts AC. So between that and center we should have roughly 15. Yep. Cool, it was just I had the meter on the wrong scale. I wish someone had shouted at the screen then. Your multimeter is on the wrong setting. Alright, so yeah, I knew that was going to be an issue. I have to bend that rectifier over just a little to get the plug in. There we go. Nice. So the board is now connected to the transformer. The dim bulb's not bypassed yet. So I'm going to go into voltage DC, and well, I'm going to stand back from it and power it up. No unusual thing going on the dim bulb. So pin 1, 11.15. Okay, so far so good, so I'll just turn that off. I will now install the relay at least, and just make sure that the relay engages and it doesn't blow the regulator up. If I can get that unplugged, it would be nice. It doesn't want to come unplugged. There we go. So let me solder the relay in and we'll test again. Okay, relay is in, and you don't actually have to build it this way. I'm just doing it this way because it is a prototype and I want to make sure before even releasing it as a project that it's not going to blow up, basically. So I'm just going to check these. Ooh. Stupid button. And I'll just check that these connections between right in and right out are not continuous, which they aren't because the relay is disengaged, and these aren't either. Alright, so I'm going to power it up again, and well, nothing much is happening. Well, that's odd. Why is the relay not engaging? We should have, yeah, we've got 11 volts coming across to the relay coil, and off the emitter of that, should that's not right, the collector rather. Nothing. What I think it is the voltage is too low for the RC network to charge quick enough. It is coming up very slowly, but it's only at like 0.1 of a volt. So I'm going to continue on testing with the transformer for now, and I'm going to plug in the IC, and I'm going to plug in an LED so we can see if the flashing circuit is actually working, and then I might pump in a DC voltage into the circuit just to make sure that it does actually indeed work. I could probably put the filter caps in as well, so I need to put this in here like that. Alright, it's not bypassed. Yeah, well, the flashing circuit is working and nothing went up in smoke, so yeah, there's just probably not enough voltage to drive the relay. Alright, so in that instance I am going to hook it up to a DC power supply. Alright, well I've got my DC power supply hooked up at 30 volts on one AC side connection, which is one of these diodes here, and the negative going to one of the ground points. I'm pretty sure that diode, the 1N4148, comes off of this side. I'll have to double check my schematic to make sure that that is true. Indeed it is. D3, which is the diode that goes to the RC network for the relay, is at this point here. So I've got the current limited to 100 mA, so I'll turn the output on. Excellent. Oh, well, the relay did just engage, and we're drawing about 62 mA. I'm not really worried about half the power supply not working. So between ground and the positive output, because that's the only thing that's getting any voltage, we should have roughly about 28 volts there, something like that. Ground's over here. We have 29, which is okay. So I can actually test the operation of the protector by the positive side at least, by bringing a jumper wire to one of these input points here and see what happens. So I might turn this off for that. Okay, turn it back on. Relay engaged, right input, drops out. It does sound like there's not quite enough voltage getting to the relay by the clicking sound it's making. Anyway, left in. Yeah, the circuit is detecting DC just fine. So, I'm not sure, that relay doesn't quite sound perfectly right. So if I bring my multimeter in on DC and I measure from, it's just caught around me, sorry. There we go. Measure from this jump connector. My multimeter probes are messing with my phone. Measure at the cathode, the anode of this diode, which is the negative going side. And we've got 10 volts there. Yeah, it should be enough. So, alright, well it didn't destroy itself. However, I'm going to have to turn that off now. I'm going to have to put it on a proper 35 plus minus supply, which I don't have, off of a transformer, just to verify that it doesn't blow up. I mean, I do have a transformer sitting in the AEL-2011 power amplifier, well, amplifier sitting off to my right here, but I don't really want to pull it apart just to test this. So I also have another 25025 volt transformer in the base amp, but I don't really want to pull that apart. I'd rather have the transformer sitting on the desk here. During editing, the first 30 minutes so far, I had a thought. I actually do have a 22022 transformer, which came out of a Technics amp, in this power supply I built last year. Now, the secondary AC fuses are both blown, so the DC side of the circuit doesn't work anymore. It's only because the output was shorted at some point. But the transformer's still okay. So what I might do is I might pop the lid off and find a way of gaining access to the secondary of the circuit before the fuses, and then pump that with the dim bulb through the power supply module into it, and well, we'll see if it will function at that voltage. It's only like 6 volts total AC less than the 25025. Now I found with the 25025 transformers, depending on the time of day, the AC output of the transformer is roughly more like 23,023. So let me get the top off of this and find a way of connecting in some wires to the secondary into my module, and we'll test again. Well, luckily I haven't actually insulated anything at the fuse holders here, so I can actually get some clip leads on there. That's the AC input, so I believe, I'm not sure if the fuses are still in there, I think they are. So if I connect a clip lead to here and one down there, which is awfully close to that screw terminal, just got to be careful, I should be able to connect it to the circuit and just find a good ground point. Alright, got some bodge leads connected in. Haven't got a ground connected yet, but that's fine. It's connected to the dim bulb. The dim bulb is not bypassed. So I'll turn the dim bulb on, then I'll turn the supply on. Excellent, we've got 46 volts AC there. So after rectification that should be closer to 65, something like that. Alright, let me get ready to hook it up to the power supply with a ground and see what happens. Right, so it's hooked up to the power supply, nothing is shorting. I'm just going to the ground point of the PCB for the ground lead. Now, this is kind of questionable way of testing things with everything exposed like this, so just adhering to basic, electrical safety, and you should be fine. So with the dim bulb still not bypassed, we'll look at the module, I'll power it up, and if anything goes off with a bang, it'll be captured on camera. So here we go, turn it on. Nice. Relay's still not engaging, but there it goes. It was just very slow. Excellent. Okay, well that does work. So let me turn that off. Got instant off. I'll bypass the dim bulb now. It is kind of very slow. There it goes. And yeah, it just clicked in. It may be that my resistor in the RC network might be too high now. But we've got what looks like a working circuit. So, alright. Let me just verify what the output voltage DC wise is. Okay, so let's see, between positive and negative. No, that's close, 62 volts. So that should be 30 volts roughly, plus minus. Yes it is. Okay, that's fine. The heatsink's starting to warm up, which is going to be expected because there is about 65 mA running through it. Okay, let me do the DC protector test again. So I'll turn it off for that. I want to connect to the VCC but not short out to VEE. Okay, turn it back on. It'd probably work a lot faster at the plus minus 35 volt, but yeah, it is pretty slow at engaging. I've got a 330k there instead of the 150 that was there originally. I may have to change it back down to 150 yet, I don't know. There it goes. Could wait for it to reset, which it's going to do soon. I know it's kind of boring waiting for a relay to engage, but there it goes. Carefully connect to negative, and it detects the negative going pulse. Excellent. Once that relay engages again, I'll make sure that we've got continuity across the input and output points. So, yes we do, yes we do. Excellent. And if I turn it off, we should have nothing now, which we don't. Excellent, so the power supply is actually working. It's not going to self-destruct when you apply an AC voltage to it. Okay, so I've got my power supply module on my DC power supply set at the worst case scenario voltage, because it's being halfway rectified off of the AC signal, so we're not going to see a steady DC voltage. And the reason that it worked on the breadboard fine was because I was pumping in like 30 volt DC to test it, and well, it's steady DC, so it is going to work flawlessly. However, that's not the case on halfway rectified, barely smooth DC. So I've got the supply still with the 330k resistor in, and I'll turn the supply on. And as we see, it's reacting exactly the same way as it is on the 22 volt 022 volt transformer. Okay, so if I turn the supply off and I go back to my 150k resistor that was in the original circuit, and that's easy enough to do because I've already unsoldered it, and I now insert the 150k in its place. There we are. Now I've been messing around for about a minute, so that should have given it enough time for these two filter capacitors down here to discharge. And I turn the supply on. That's much more acceptable. So I'm going to say 150k is what's supposed to be there. Alright, I got it on the 22 volt transformer, and let's see if that works better. And there we go. That was about 4 seconds. So with a 25025 volt transformer, I reckon it'll be around about 3 seconds. Just to verify that, I'll let it discharge for a second. Try again. Yeah, it didn't discharge quick enough, but it is actually functioning. So I'll turn it off. I will go do something for a few minutes, come back, and then run the test again. Okay, it's been sitting a few minutes, so let's turn it on and I'll count. 2, 3, 4, 5. It's about 6 seconds. So that's acceptable, I think. And the relay's not struggling to mechanically engage as it was before. So as I say, with the extra, 6 volts total on the transformer, that should be more closer to 4 seconds. So I'm going to make the change back to the original resistor it was supposed to be, which was 150k, and call it done. So I'm going to upload this video now, and over the next couple of days I'm going to work on the articles for both the power supply and the power amplifier module, release them together. Then I'll put a community post on my channel with the available PCB projects. And in the PCB projects, both PCBs will be linked to each other as a project. So the power supply will be linked back to the power amp, and the power amp, vice versa, will be linked to the power supply. Anyway, I'm happy that it works properly now, and yeah, there's not much more else to say on this, so watch this space. I'm the Astro 30, and if you enjoyed this video, please remember to go down below, like, comment and subscribe if you haven't done so already. And as always, this is the Astro 30 saying see ya, thanks for watching, have a great day.